Thanks everybody for those of you who are in the, thank you. Those of you who are on the West Coast, thanks for waking up kind of early to listen to me. I know it's a little earlier than it is here. And let me thank you all for this opportunity. You know, I think it's, I've been talking almost every day about the pandemics, and it's kind of a relief to not talk about it directly. I'll talk about it indirectly, of course, as we move on along the talk. But so what I thought would be kind of interesting for everybody was to first, in the first half or so of the lecture, to just talk a little bit about some of my ideas concerning epistemology, about how science actually works and how we construct a narrative that describes the world as a whole. And then on the second part, move on to talking about some reflections that I've had over the years concerning an effective engagement with the public, both in the classroom at different levels of education. I mean, there are many ways in which you can talk about how do you teach STEM disciplines, you know, in general, from elementary school to postdoctoral levels, and also in the public sphere. So I'm going to try to do a little bit of each. And David was saying that if whoever wants to ask me a question during the lecture, please do so. I think that'll be fun. Just unmute yourself, I guess, and go for it. And hopefully this could become more of a conversation. So I'm going to start by sharing my screen. Hopefully it'll all work and we'll be able to see everything. And I'm going to start with my PowerPoint presentation from the beginning. So, so the title of the lecture is kind of a playing words, from the nature of knowledge to the knowledge of nature, reflections on the teaching of science in the classroom and the public sphere. And I would like to, and you're going to see why I have this pretty picture of an island that, considering global warming, is probably not going to be there for very long. But while it was there, it was this picture was taken. And you're going to see that this is a metaphor that we're going to go back to, called the Island of Knowledge, later on. But I'd like to start by quoting from Albert Einstein. You know, a couple of quotes from him, just to kind of contextualize a little bit what I want to talk about. So Einstein said, "What I see in nature is a magnificent structure that we can comprehend only very imperfectly, and that must fill a thinking person with a feeling of humility." And that, of course, is quite remarkable. It's a great statement for many, many reasons, because there is a tension among scientists, right, between what it is that we can do in terms of understanding nature. Can we kind of figure everything out? Or are we fundamentally limited on what we can understand of the world? And this has been a tension for a very, very long time. I mean, if you can go back to ancient Greece, Plato and Aristotle are already kind of debating this. Plato would say that, you know, the fundamental truth with a capital T, right, has to do with the world of ideas, how we understand reality with our minds. And Aristotle was a much more pragmatic guy. And he said, no, you got to look at the world. You got to kind of try to make sense of what we see. So trusting our senses to construct a description of the world. And here Einstein is saying that, you know, nature is wonderful, is magnificent, but we can only comprehend it very imperfectly, meaning there are limits to what we can do with science. And because of that, any person that engages rationally with trying to understand the world should be also feeling quite humble by the vast amount of ignorance that we have about nature. And case in point, I think the current pandemic is a clear example. It's almost a slap on our faces showing that, yep, we know a lot, but look how much we don't know about this single virus and the damage that it's causing to us, you know, as a species. So the other quote from Einstein, it comes from, well, it's somewhat related to this picture here. I love this picture because, you know, you have like the poor little goldfish, you know, stuck inside inside his fishbowl, you know, right in front of this gorgeous ocean in sunset, right? And you would say this could actually be a beach in California, who knows? But the point is that you would immediately say, well, you know, I'm not the goldfish, right? I am the photographer taking the picture because I have the picture of the whole of the world as a whole, and poor goldfish who is so limited that can just kind of perceive the world, you know, sorry about that, folks. I just have to kind of mute my phone. Perceive the world as that there is something beyond his fishbowl, but yet he can't quite grasp it. And this is exactly our view. We are not the photographer in this metaphoric picture. We are actually the fishbowl, that we have a very limited understanding of the world around us. We know there is so much more, right? But we also know that there's only so much that we can see. And this statement that I'm making right now is not the statement that a lot of scientists would go for. In fact, if you go to the theoretical physics department at Stanford, a lot of my colleagues there, they would say that through reason, we can definitely kind of get to the final knowledge of the natural world, construct a so-called theory of everything, right? And that sort of statement for me is epistemologically wrong, first of all, and it also sends the wrong message to people about what science is and what science can do. And so Einstein would look at this and he would say something quite unexpected. He would say this, you may have seen this quote before, it's quite famous. He would say that the fairest thing we can experience is the mysterious. It is the fundamental emotion which stands at the cradle of true art and science. He who does not know it and can no longer wonder is as good as dead. And he continues saying it's like a snuffed out candle. So what he's saying here is something very important, is that the engine for human creativity is precisely this kind of connection, this urge to know what's beyond our immediate grasp, you know, what you can call the mysterious, what he's calling the mysterious. And more importantly, you know, this is the fundamental emotion that is, and this he brings together arts and sciences here, so that the human creativity really springs from the same urges to engage with the mystery that is around us, right? So he's saying, what does a scientist do? Well, the scientist is actually trying to figure out this mystery that surrounds us. What about the artist? The artist is trying to give expression to the unknowns that exist within ourselves and the society in which we live. But it's all about this engagement, this flirting, I would say, with the unknown, right? And I think that's very important when we talk about science in general. You know, whatever audience we discuss, you know, we are addressing, sorry, we should be thinking about this sort of questioning, because that way you're not just saying, look, science is just a bunch of data. Science is all about engaging with numbers and formulas and very, very kind of automatic, mechanistic prescriptions. No, deep down, the very fundamental urge that we have to understand the world is a much more existential connection with all of humanity and all of humanity's urges than just the more technical expression of science, you know. And I think that kind of brings people together, connects them with science in ways which I think are much more engaging than if you just go and you have, you know, this is just Newton's equations of motion, or this is the law of gravity, or this is the mitochondria inside a cell, you know, memorize this whole stuff and say, no, science is part of the human drama. You know, it's part of how we make sense of the world that we don't know. And the fundamental question that is in here, you know, is our grasp with reality, right? So just as an anchor to this conversation is, how do we know what is real, right? So for example, right now, when you're listening to me, you can see me, you can hear me, you are in your homes, you are sitting down. So your senses, right? Your five senses are receiving information from the world. This information is being integrated by your brain. And with that, you construct what you could call a map of reality, right? I mean, what's reality around you? However, our sensorial perception of the world not just is very limited because we're always focusing our attention. There's all sorts of stuff going on around here that we are not focusing on right now. But further than that, our senses are very limited in perceiving what is happening here just because we as humans evolved next to a sun that maximize, radiation within the visible spectrum. And so there's all sorts of invisible electromagnetic radiation around us, like infrared from our own bodies, whatever is warm. Or in my case, I'm in my office, there's a bunch of ultraviolet radiation from those lamps up there, and there are radio stations beaming in radio waves. So there is all this context of reality, which we cannot perceive through our senses, but nevertheless are very, very real indeed, right? And that is what is very important to tell people. It's not just about, oh, this is the world in your face. You see the stars, you see the moon, but look, you do not see so much of what's going on around you. So how do we know what is real if our perception of reality is limited, right? And just to give you a couple of more quotes, which are very much to the point, is this one, that from Heisenberg. So Heisenberg, if you don't remember, is the guy from the quantum uncertainty principle, right? And he basically was very much engaged in this idea of how can we humans, with a limited sensorial perception of reality, construct a narrative that we call science that is complete. And he says, you just can't do it. That what we observe is not nature itself, but nature exposed to our method of questioning. Meaning, our conversation with the natural world is a very human conversation. We do not have the God's eye view, like I can see everything from an omniscient and omnipresent kind of way. We only see parts of the world. And the questions that we ask are very much contingent on who we are, how we evolved in this planet, what sort of sensorial ability we have, how our brains are wired in order to ask questions. There's a whole very interesting conversation. In fact, not far from you, George Lakoff in Berkeley, he wrote a book about the basics of mathematics. Is mathematics kind of an invention of the human brain, or is it a universal truth, in the sense that Plato would like it to be, right? Like there are fundamental mathematical truths about the universe. And his argument is that it is not, that mathematics is very much embodied, it's very much part of how we observe the world and talk about it. So this is could be a whole other talk about, is mathematics discovered or invented? One of those questions that it doesn't really have a final answer, but it's a very important question to be asking and figuring it out. Well, when we go beyond mathematics and ask about what about us and nature, how can we have a map of reality? Well, the map of reality that we build is a very human map indeed, meaning if you have an alien civilization out there that is also capable of scientific questioning, their questions are going to be very much contingent to the way they evolve in their environment, in their planet. And then finally, I love this one. This one is from Bernard Le Bovier de Fontenelle. I don't know if you ever heard of him. He's an amazing guy. So he was in the late 17th century, he was one of the most important intellectuals in France. And he wrote a book called Conversations on the Plurality of Worlds, where basically it's a wonderful book about the possibility of extraterrestrial life. 1686, this guy published the book, right? 1686. And the book is itself quite interesting in its structure because it's him talking to a marquise. So the protagonist is a female, which at the time was unheard of. And not just that, she was incredibly witty. And she was always asking him, who was the philosopher, very hard questions about nature and life and other planets. And at some point, she asks the philosopher, so what is philosophy, right? And he says, I don't know what philosophy is, but I can tell you this. It's based on two things only, curiosity and poor eyesight. The idea being that, you know, we are always wanting to know, right? That's who we are. We want to know. That's part of the human nature. We are curious, but we're myopic, right? We can only see so far, right? And so there is a constant clash, right? A sort of a strain, a stress between wanting to know everything and not being able to see everything. So if you don't see everything, how the heck can you know everything, right? So that is beautiful. I think that nails it down quite well, you know, about what is the nature of science. Is exactly that, is a match between our curiosity and our poor eyesight. So these fundamental limits to our knowledge of the world are very important when we're discussing the way science operates, because traditionally, science is a very top-down thing, right? The way we talk about science in schools and mathematics is sort of like, this is the truth about the world, right? And I think that disengages people and in fact antagonizes people. And I think a lot of the anti-science narrative that we are perceiving nowadays, you know, the flat earthers, which are as big in Brazil as they are in the US, or the anti-vaccine people, or the global warming deniers, those people are reacting to this kind of power hierarchy that is so present in the scientific narrative. You know, to a certain extent, that is also, the fault is also within the way scientists talk about science itself, right? So I think that bringing this upfront about how science operates and why it is limited in its tools and in its reach, I think humanizes science, you know, and talks about not just about its successes, you know, science solves this, science solves that, but also about its failures and its limitations. And that's not, of course, taking away the beauty and the power of science, but it's making science more approachable, more human. And I think that is extremely important, because once it's more human and more approachable, it becomes more easily accessible to people, right? Just a fun example of this, you know, so as you probably remember, you know, from your readings of classic philosophy, in, let's see, in volume 7 of the Republic, Plato, who, by the way, you probably know this even better than I do, that book is really a pedagogical manual, right? I mean, Plato wrote that book to train the philosopher kings, right? It is really about, how do I educate the leaders of the time? You know, what is the best educational approach to actually have enlightened leaders, the so-called philosopher kings, right? And if you read it, you're going to see, well, you know, they should know a little bit of mathematics, they should know a little bit of languages and philosophy, and they should know music, and they should know martial arts and military strategy, and they should know astronomy. And basically there's a curriculum, you know, it's a plan, right? To how do I educate these people? But in that discussion, he wants to show that the true final knowledge, right? The true nature of reality can only be understood by the brain, by rational thinking, right? And he constructs this allegory called the allegory of the cave. Here is a cartoon between the allegory of the cave and Neo from The Matrix, right? So Keanu Reeves. But the allegory of the cave basically says this: if you have a bunch of slaves that have been chained since birth to only look at the cave wall in front of them, their reality is going to be what they see on that cave wall, right? So whatever projections, shadows, dancing, moving on the cave wall will be their world, right? And they cannot turn back. They cannot see that behind them, there's this big fire, raging fire burning, and there is a fellow there, or some fellows, holding statues and projecting the shadows of the statues onto the cave wall. So because they can only see forward and not backwards, they have a very limited way of thinking about the world. And that is an allegory to our limited engagement with reality through our senses. You know, so Plato would say, hey, if you trust your senses to go for the ultimate truth, you're going to be always wrong, because the ultimate truth can only be understood in the realm of the mind. So he would say, the only perfect circle that exists is the circle you can imagine with your brain, not the circle you can draw with your hand or even print with a printer if you bring this to modern times. So the cartoon is basically that. So you have a bunch of slaves here. This is the wall, the cave wall. Apparently there's some kind of unicorn doing some stuff there. And then there's this, one of them is saying, it is prophesied that one day a chosen one among us will break free of this world and reveal to us the true nature of reality. And then you're saying that's really unlikely. You know, there is no such thing as us revealing the true nature of reality. And there is the guy here, the very nasty kind of naughty face, you know, projecting the shadows on the wall, right? And that is the problem, which I would call Plato's error, that he always put ontology before epistemology. That is, he would put what are the fundamental entities that describe reality. In his case, it was about his fundamental forms before our perception of the world. And I think we just can't do that. The epistemology is always preceding ontology. And if you look at the history of science through the millennia, through the centuries, if you want to start in pre-Socratic Greece, you're going to find that, you know, ontology is always changing, right? I mean, what are, you know, oh, it's all atoms. And then, no, it's not atoms, it's atoms and forces. No, it's not atoms and forces, it's fields, fundamental fields. You know, so the way we describe what is physical, what is the nature of physical reality changes. So this ontology is always ongoing because it depends on the way we engage with the world through what we call epistemology. Okay, all right. So just to, I don't want to go over because I want to talk about the more educational part of stuff as well. So I'm going to put my watch right in front here. Just, you know, usually I would give some examples. This is taken from my book, The Island of Knowledge, but in which I would represent these limitations of fundamental knowledge in the cosmic realm, in the material realm, and the cognitive realm. Let me just briefly talk about the cosmic part, although this is a more general intro, which is that the way we amplify the limits of our senses, you know, how we can see stuff that is very far away, how we can see stuff which is very small. Well, what do? We amplify our reality through our discovery tools, right? So you have radio telescopes, you have powerful microscopes, you have particle accelerators. This one here is at CERN in Switzerland. You have a little person, well, a person here. This thing is about a 6-story building high. It's a detector from, it's called the Atlas detector at CERN. This is an ancient astrolabe from the 12th century, you know, it's still Muslim in origin. And this thing here is the Hubble Space Telescope. So all these tools, what they have in common is that they amplify our grasp of what reality is, right? And that is how science creates a map of the world that goes way beyond what we can perceive through our senses, because you can't see bacteria, you can't see faraway galaxies, you cannot hear black holes colliding, you know, you cannot get the gravitational waves that come from collisions of black holes, but through our tools we do that. Now, the success of this narrative is so huge that you could say, well, you know, are we going to get to the end, right? And my point is that that is just not possible, because every tool that you build through technology has a limit, right? And so there's only so much information you can get from a specific tool. You can improve the tool and that will improve your knowledge, but there is always a limit there, which means that there is always something beyond what you have at present that you cannot grasp, right? And I think that's very important. And that is what I call the unknown that surrounds the island of knowledge, perhaps what Einstein called the mysterious in the initial quote that we had. But it's very important to remember that theory does not invent reality. The only way we can actually understand what's going on is when we observe stuff, right? You can't just theorize about the fundamental nature of the world. You have to actually measure it and test it. And because of that, we are fundamentally limited on what we can say. Here is an obvious example of that. You have 3 visions of the universe, okay, over time. So on the left here, and of course, for the people that live in these different times, this was it. This is the cosmos that I lived in. And so this one, you have Atlas here, poor guy carrying the whole cosmos on his back, but you have Earth in the center, and then you have the 4 elements, and then you have the orbit of the moon, and then it's actually a sphere of the moon, and then Mercury, Venus, the sun, the other visible planets to Saturn, the stars, and then you have the so-called primum mobile, which is how the Aristotle and the Greeks believed that the so-called unmoved mover, the guy who would generate all the motions from outside in, would create the mobility, all this stuff that we see in the cosmos. So this was the model of the universe for about 2,000 years, right? So from the Pythagoreans in the 6th century BCE all the way to Copernicus in 1543. So you're talking about 21 centuries, right? These guys believed in this until Copernicus came in. I mean, there are all sorts of nuances that we can't talk about right now and this was it. This was the story, right? That was the story of the world. This is where we exist. And then, of course, came Copernicus and put the sun in the center, and the whole arrangement was changed. The Earth became just a planet, and just like all the other planets, and that, of course, changed the whole hierarchy of the cosmos and how it connected to ethics and values. The Christian, the Catholic Church used this model from the Greeks, transforming it into this theological structure of the universe where the hell was the center of everything, right? Remember that the devil and hell lived underground, and as you went up, you had the heavens with the gods and the angels. And so the goal of a believer was to, of course, engage eventually with the gods, with God and the angels in the heavens. So there was a verticality, which is translated in the architecture of Gothic cathedrals, for example, that this model of Copernicus kind of destroys, right? So people were lost in disarray. There was a lot of emotional anxiety about this, especially when it was realized with the development of the telescope in the early 17th century, that the universe was much bigger than people could understand. There were many, many more worlds out there. And then, of course, if you jump to the 20th century, you have this as our universe, right? A completely different reality, right? Why do we have this? Well, we have this map of the world now because we have the Hubble Space Telescope, right? So this is one of the most spectacular, in my humble opinion, pictures ever taken. This is called the Hubble Deep Field picture. I like it so much that I'm giving it to you in full screen. There it is. Each one of these blurs here is a full-blown galaxy, okay? That means that each one of these little ghosts here, ghost-looking things, is kind of like our Milky Way, which has hundreds of billions of stars, with trillions of planets, and each one of them is a galaxy on its own. Even these little, tiny little blurs here, they just happen to be smaller because they're farther out. So you're talking about a universe with hundreds of billions of galaxies expanding, completely different universe than, of course, the Copernican universe and certainly the Greek universe, right? Now, this sort of transition in worldview only is possible because we developed the tools both from an instrumental perspective, but also from a theoretical perspective to describe what's going on. And still, even with all of this, we have a limited engagement with the natural world because we can't see everything that is out there, right? Both on the very large and on the very small, right? So when I talk about this, I talk about the Copernican narrative, which is the Copernican narrative that says that, you know what, the more you learn about the universe, the smaller we become, right? I mean, we're just one planet in one galaxy. But I realized over the years that that sort of conversation was not very productive, you know, that if you want to really make science and the learning of science into a more transformative tool for the modern world, you have to create a post-Copernican narrative. And beyond Copernicus, what are we learning now that is so important about the world that makes us matter again? Because what has happened since the 16th century is that people felt diminished by science. That, well, science is always telling us that we don't matter, that we are nothing, that we're just a little grain of dust in the universe. And I am trying to invert this narrative to show that, yeah, but wait a second, because when you do look at the universe and you start looking at what we have a whole new branch of astronomy called exoastronomy, the astronomy of planets moving about other stars. And we're finding is that our world is extremely important. That Earth is a very rare planet with very rare astronomical properties. And it is because of those properties that we are here, that life was sustained for over 3.5 billion years in this planet. So I'm trying to bring back to the narrative a different perspective where we and all forms of life, you can call it biocentric perspective, are very important. And we matter because we are the ones that think about the universe, that construct this sort of conversation between us and the world that, as far as we know, no other species, certainly in this planet, can do. And I'm going to skip over, there is also this stuff about what we know and don't know about the material world, but I want to listen to you. I just want to mention that this guy here, so this is a self-portrait by Rembrandt, uncharacteristically happy. He usually is a very kind of depressed guy, right? I mean, if you look at the paintings, they're all dark and he's happy. Now, who is he? Well, the name of this painting is Self-Portrait on the Image, based on the image of Democritus. Now, Democritus was one of the pre-Socratic philosophers, one of the atomists that believed that knowledge was the path towards freedom. He believed that the more we learn, the more we are capable of reflecting, of critical thinking about the way the world operates and how we fit in it, the happier and freer we're going to become. It's going to be a liberation from old superstitions. And because of his confidence in his way of thinking, he became known as the laughing philosopher. So there he is, so the idea here is that education, that the power to reason about what the world is like and how I fit into it is an empowering tool, is a self-empowering tool. And I think this is the sort of lesson that we can bring to our conversations in the classroom and beyond. And then I'll go on about limits in cognitive sciences and AI and can machines think, but I'm just a little worried that that we won't have enough time for the conversation. So you can ask me questions about that. There'll be an opportunity for me to go back to it. But let me instead quickly review what I mean by the island of knowledge and jump into the other part of the talk. So the idea then is this: if you picture knowledge as fitting in an island, right? As every good island, it is surrounded by, you can call, the ocean of the unknown, right? Meaning what we don't know of the world. So the interesting paradox about knowledge in general is that you would say, there are two ways in which you can think of this. This island is going to grow because knowledge is growing, and eventually it's going to cover the whole ocean of the unknown, and we'll have no more questions to ask. Believe it or not, many times over in the history of science, people reach that conclusion, right? Like in the late 19th century, Lord Kelvin, one of the greatest scientists of all time, said, you know what? Our job as physicists, it's pretty much done because we know mechanics, we know electromagnetism, we know thermodynamics, the study of heat. Everything left for the future generations is to tidy up here and there little details. And then boom, came quantum mechanics and the theory of relativity and turned everything upside down. And of course, is a clear lesson that Lord Kelvin was profoundly mistaken about what he's talking about, because knowledge by nature is incomplete and it's always developing. And in fact, as the island grows, so do the shores of our ignorance, which are the boundaries between the known and the unknown. Meaning, as knowledge develops, you are capable of asking questions that before you couldn't even contemplate, right? So that is clear in the quick example I gave you of the history of astronomy, right? I mean, with the development of telescopes and cosmology, you look at the galaxies and you can start asking questions about galaxies and the nature of galaxies and the stars in those galaxies that you couldn't even have imagined possible 2 centuries ago, right? And that is the beautiful part of knowledge as well, is that as it evolves, it allows you to ask new questions all the time. So it's not the final pursuit. There is no final pursuit. There is just the pursuit of knowledge. And so this is the representation of that. So you have the unknown here. And interestingly enough, there are also areas in this crazy map that I made here of unknowables, okay? And I'm not Dick Cheney, right? Is that him that you say the unknowns and unknowables, etc. But is the idea that there are fundamental questions which are scientific questions that you can ask that cannot be answered, right? And one of them, for example, and again, a lot of my colleagues that are inside the paradigm of the Platonic way of thinking about reality would be very angry about is the origin of the universe. You just cannot possibly answer that question within the scientific narrative, okay? And it's a very simple argument. Another one is the origin of life on Earth. Even if we make life in the laboratory, which there are lots of very smart people trying to do, you cannot know if that is how life evolved 3.8 billion years ago, unless you can prove that there is only 1 or 2 biochemical pathways between no life to life, right? So there are many of those, there are quite a few of them that I can give you examples of, but the idea is that, yes, there are unknowable science. So it's not that science is powerless, is that science is powerful, but not all powerful. And I think that lesson of humility is extremely important. Okay, so that's what I'm trying to say then, when you're a learner, science is humanized as we tell it, not just through data and facts, but through its history, the failures, the successes, portraying scientists as human beings with questions, with ambitions, with prejudices, and that happens all the time, with partnerships with the state that somehow, that often kind of drive scientific inquiry in ways which may not be the best ways, right? I mean, this alliance between science and the state is as old as Archimedes, right? And it's obviously incredibly present. You see how many scientists work for the Defense Department, etc. And always illuminating, these connections and tensions between science, religion, philosophy, and culture. So there is not science as a thing by its own on itself, but science immersed in a cultural context where it makes much more sense to think about it, right? And the idea then is also to be very careful and not to portray science as, oh, this guy is anti-science. No, quite the opposite, because it is precisely through failures that we learn. We can only learn when we make mistakes, right? I mean, and it is absolutely essential to embrace failure as part of the learning process. And this is good because a lot of students of science feel like that they are failing because they can't get to the answer right away, or they can't get to the answer at all. But when they understand that, Newton failed too, Einstein failed too, this is part of being human, and I think that makes it easier for people to accept their limits and think them not as obstacles, but as triggers to knowledge, to knowing more, right? And that it really is about finding meaning in the quest, not in the final answer. It's about the process of discovery, and I'm going to talk a little bit about that in a sense, and in a second. And it's really about the searching, the trying to finding things out that really drives this human connection with the mystery or the unknown that makes us matter. That we are always trying to expand the boundaries of who we are, right? And finally, the notion that science is really not the owner of truth, but it's really an ongoing self-correcting narrative, right? I mean, it is always part of something that is growing, right? And, in a more kind of lyrical way, you could say that it is the map of what we call reality is an ever-shifting mosaic of ideas. You know, I mean, it is ideas about the world. I gave that quick example of how our notion of the cosmos changed in the last 500 years. But this is the notion. It's really an ever-shifting mosaic of ideas. We're always changing the ways we think about the world, about society, about money, about economics, about how do we best teach students. I mean, these are all part of our scientific approach to knowledge and how we get ahead.
Marcelo, this is David. Can I interrupt you for a moment?
Absolutely, please.
Yeah, so I'm clearly very sympathetic to all the ideas that you've put forward, but I'm a little concerned about the island itself. Because you mentioned earlier anti-vaxxers, climate change deniers, flat earthers. How do you define the island? How do you say we actually know some things? We know that the earth is not flat. We know that vaccines will not make you stupid. So how do you defend that idea in the context of this larger sort of relativistic picture that you're painting?
So that's a very important question, because it's a matter of authority and expertise, really, you know, and how do we attribute authority and expertise to a group of people? So the way science operates is by consensus, right? I mean, I think the fundamental way that we say this is right or this is wrong is you publish a study. The study is going to be looked at by your peers. It will be either validated or invalidated. And through this, if it is validated, the community endorses it as part of the accepted knowledge of the time, right? And what needs to be transmitted, and the failure of transmission that has caused the rise of anti-vaxxers and flat earthers and all of that, is precisely the disconnect between what scientists and the scientific community are doing to promote their knowledge and the general public, you know, because, and I agree with you that there is a serious issue there. And I think even before our whole COVID-19 story, the global warming situation is untenable. You know, I mean, there is a serious problem because it was a conversation which was essentially scientific, you know, about is there global warming or not? Yes. Is it caused by anthropogenic sources or not? Yes. Okay, that second part offends all sorts of different groups. And because of that, the conversation was politicized. And I think a lot of what has happened is that many scientists try to assert the truth of their discoveries in a sort of, I would say, top-down way, which may not be the right way, you know. And also the other problem that a lot of these conversations that you brought up, you know, like anti-vaccines and everything that we do in science, especially when we're talking about large science, like vaccination of a population, has to do with statistics, right? And so to a small number of people, certain vaccines can be bad, right? And that is sort of like the price you pay for the benefit of a much larger group. The question is, how does this ignorance of statistics, because that's really every statistical distribution has tails, you know, and how do we explain to people that if you're protecting 100 million people, maybe 1,000 suffer, right? But we are talking about a factor of 1 in 100,000, and that's still mostly beneficial to everyone, you know. The problem, I think, becomes when science is used by the state as a power tool to impose on people's freedoms. I think that is perhaps one of the reasons why you have these movements, is that the people feel disenfranchised because, you know, the scientists, the government are telling us to do this, this, and that. We have no power over our own lives. I don't want to do it. So it becomes a rebellion. And but I think the construction of knowledge from a scientific perspective is really community-based, and it has a methodology for it. So it's a complicated problem, but I hope I addressed some of the issues there. Okay, am I good? All right. Oh, you're muted. Okay, I'll continue from where I was. All right. So to conclude this, just making a few remarks about the two classrooms, the schools and the world, because there are different ways in which you can think about the role of science for the population as a whole. You can think about formative and informative education. Formative, I would say, is when you are training people in the sciences with the goal of, as they go into college, they will become scientists themselves. Informative is basically about every citizen in a functional democracy should know enough science to make sure that he or she can actually vote and make decisions appropriately, for the common good. And this sort of informative education is what people call the public understanding of science in general, right? But for example, in the universities in the United States, we have this beautiful thing called liberal arts education, which I think is absolutely essential, which is the notion, as I don't have to tell you this, but just to be complete here, the idea that if you're going to become get a bachelor's degree in art history or in biology, you still have to know and learn and engage in courses in many different fields so the education is balanced, right? It's a little bit the notion that you want to open up the minds of people to other ways of knowing, not just the way of knowing of your particular choice of career, right? And this is not very common. For example, in Brazil, we don't have this, right? Which I think is a real problem. We should have this because those folks that say graduating in government, political science, economics, they may reach positions of leadership in society, knowing very little or nothing about science. So how do you supply a basic knowledge of science to those who are not going to be scientists so that when they are in positions of power, they can deliberate and make choices which are reasonable and responsible, right? So that is why I like to think that those sorts of courses, those sorts of formative, informative discussions of science are extremely important. And I don't think that in the United States, there are many more public voices for science than in Brazil. There are lots of my friends here in the United States that do what I'm doing. In fact, at Stanford, you have Lenny Susskind, who's a guy who writes a lot about physics for the general public. There are people in different schools doing this. In Brazil, there are very, very few, right? And the whole structure of Brazilian education has created this kind of vacuum between what's going on in academia and the rest of the world. And to the point that kids grow up without ever seeing a single scientist in their lives, right? I was actually one of them. I decided to become a scientist, a physicist, without ever seeing a physicist until I was 18 and I got to school, to university, which is kind of crazy, right? So the idea then is that telling, as I mentioned before, telling science not just as a technical approach, but as a story of discovery, a drama of successes and failures, of power and greed and disputes like Galileo and the Inquisition and the church, etc. And explaining that science is really a mechanism that offers a methodology for self-correction. It doesn't always strike, the correct answer, but it gets there eventually. It approaches something that becomes a useful answer over the years. The other thing that I found is extremely important is that the idea of experiential and active learning is that, and you can do that through a book, not just if you have a lab in a classroom, but you can do it through a book with thought experiments. You can create situations that you're reading. So imagine that you are in a spaceship and this happens. And so the reader or the student becomes the explorer. This notion of playfulness in the teaching of science so that it becomes an exploratory way of learning, and I think that's extremely important, and also, if you want to explain why do you need to learn about this stuff, because a lot of kids, I have a teenager, like, why do I have to learn math? Why do I have to learn science? And well, actually he doesn't say these things, but a lot of his friends do, because, being my son, he has no choice to understand why does he need to learn science and math. It's really about self-empowerment, understanding how to think critically about what are the fundamental questions of the world in relation to the survival of our species, the relationship between us and the environment. These are the questions of our time, right? And this is about self-empowerment. You as a citizen, you as a growing adult should know these things, right? And should learn how to think by yourself and for yourself. That to me is extremely important, because the educational process tends to be very top-down, right? Very like the teacher is throwing information at the students, and the students are receiving that information in a very passive way. And I find that way of teaching very old-fashioned and very inefficient. And Dave, I know that you've worked so much in the core curriculum for California, so I know that you know this much better than I do. But creating a situation in the classroom or in the public sphere where people are excited about the topics changes the whole conversation. It makes students and teachers into partners, and this partnership to me is absolutely essential. And of course, in my case, I always like to think of science as an opportunity for us to re-enchant ourselves with the natural world. And in a more specific approach, we cannot separate what we're doing in science with its impact in the world in terms of ethical choices that we need to make in the future. And it's not just about the pandemics or climate change, but it's also about the interface between artificial intelligence and the future of humanity. Is artificial general intelligence a true existential risk for humanity? Is artificial general intelligence, machines that can think by themselves, is it really a possibility in the near future, in 20, 30, 40 years, or is this science fiction? And if it is possible, what can we do to safeguard our species? And the same with the notion of bioengineering. At what point do we need to legislate what people are doing? How is the state going to regulate biohacking, which is much, much easier than nuclear hacking, and that's why it's much easier to control nuclear power than it is to control bioengineering, because bioengineering you can do in your garage. And these are questions which are the questions of our time. The questions are going to define the future of certainly the next generation. And we need to talk about this to society as a whole. And all of these questions are not just scientific. They cross disciplinary boundaries. They are they must engage different ways of learning, different ways of knowing about these topics for us to make effective decisions. So when Google is developing self-driving car, the decisions that the algorithm in that car need to make sure that it protects the driver or it protects a group of people crossing the road are decisions that involve not just the programming engineers, but ethicists and other people, other specialists, social psychologists that need to be part of this conversation. So the problems of our time are too big to just be dealt with within a one-dimensional, one-disciplinary approach. So that's my story. And of course, just to finalize here quickly, in the case of Brazil, we have serious systemic problems, right? Just in terms of numbers, right? I think there are about 3.7 million babies born in Brazil per year, and about 2.4 million of them finish middle school, right? So you're talking already about what happened to this other 1.3 million people, because you want to maximize the number of people that you educate so that they can become productive professionals, right? And the worst part of this conversation is that of the 2.4 million that finish middle school, only about 230,000 learn enough to become productive professionals, right? To go to college and engage professionally at a higher level. This is the number equivalent to Belgium, okay? And Brazil is much bigger than Belgium, you know, so there is a huge shortage of professionals being trained. And so one of the things that I've learned that the Fundação Lehman is doing is this beautiful work in core curriculum development and implementation over the last 5 or 6 years that is actually quite impressive. You know, I looked at the numbers from Sobral, for example, the Sobral experiment, and I think that is precisely how you actually create transformative change from the bottom up. You know, it's by rethinking, unifying what are the fundamental basic items of knowledge, so to speak, that every student should know. And how do you train the teachers to do this, right? And one of the things that would be very interesting for me to talk about with some of you is to create partnerships with other foundations that actually are doing this work. There are training teachers of not just passing the information. One of them is called Educando by World Fund Foundation. I don't know if you're familiar with that, but it's a nonprofit from NGO from New York. Is doing beautiful work and is impacting a lot of people in Latin America in general. And it's not just about this passing of knowledge. It's really about inspiring students to want to learn. Because, you know, you're all teachers, you know this, that the best teacher in the world cannot teach a person that doesn't want to learn, right? If you don't want to learn, there's no way you can teach that person. So you have, as you know, as a teacher, you must be able to create the fundamental conversation, partnership between you and your students so that you can create a passionate learner. And that is, I think, when education, and in particular, in my case, of course, I'm talking mostly about science and philosophy and the history of science, when that becomes a socially transformative force. So I'll stop here, and I'm happy to talk to you about questions. Thank you.